Welcome everyone to the Passive House Accelerator's 10th Global Passive House Happy Hour of our second year and episode number 62. Thanks for joining us. I'm Prudence Ferreira. I'm a senior member of the Carbon Neutral Design Group at BR Plus A Consulting Engineers and lead their Passive House team. We're an inclusive gathering here at the Accelerator Happy Hour. So whether you're new or have been here since the beginning, welcome. We look forward to hearing what Talina has to share with us tonight, which will no doubt shed more light on how to do passive house in climates than some of us are used to working in. And in general, ways to reduce greenhouse gas emissions. That's what we focus on here. There are a few things we're celebrating in climate action news. First, the government of the UK has promised to halt the decline of nature as part of a new drive to improve the environment with measures that will include legally binding 2030 targets to address wildlife loss. Second, in a court in Netherlands, there was a ruling in a landmark case today, a lot of you probably saw, that the oil giant Shell must reduce its emissions 45% by 2030 compared to 2019 levels. And this is the first time a company has been legally obliged to align its policies with the Paris Accord. And although currently the ruling is only directly applicable to the Netherlands, it will likely impact Shell operations worldwide. Another fossil fuel giant, ExxonMobil Corp, actually ceded 2 seats of its board of directors to an activist investor group called Engine Number One, and is likely going to be forced to alter its fossil fuel focus strategy and work directly to confront growing shareholder concerns about climate change. And then lastly, here in the US, the way has been cleared for commercial offshore wind farms in a 400-mile square area off the coast of Central and Northern California. And this marks the most significant action the US federal government has taken to promote wind energy along the West Coast and is part of Biden's plan to shift the nation away from fossil fuels. So I'd love if you all could join me in opening the show by unmuting yourselves and doing a toast to progress.
Progress.
Cheers to progress.
Cheers to progress.
Yeah.
Progress. Take the small wins.
Oh,
That's right.
we just started.
We'll take them all. All right. So mute yourselves and settle in. We have another great episode and are joined by Talina Edwards, sharing with us a pioneering passive house achievement from Australia. But first, over to Zach.
Yeah, thank you, Prudence. So for the video today, I went to the International Passive House Association's YouTube page to check out Open Days videos from last year. And I've had retrofits on the brain recently. So this is a video from last year's Open Days. And the reason this is relevant now is that Open Days is coming up in just a few weeks. So there's a direct connection in that way. There's also a connection to the importance of retrofits in climate action. And so I hope you enjoy this short little piece. Let's see. I hope those breakout rooms are fun. And I'm going to do some quick announcements here. I want to just remind everybody that the new website here, I'm going to show the new website, has this explainer section about Passive House now. And if you go to the bottom of any of these explainer pages, so you scroll down, you'll see this download Passive House infographics. So the infographics that we're sharing on these pages are available for you to use with a Creative Commons license. So you're free to use them and just attribute to the Accelerator. And we're hoping that people will do that. So there's lots of graphics about the benefits of Passive House here, as well as the design principles of Passive House. So please take a look and download all those files and see what you'd like to use. So every week at the Passive House Accelerator, we publish a week in preview article, and it shows what's coming up for the coming week, of course. We had that great presentation by Daniel yesterday, and then tonight, Talina, we have a podcast interview with Petra Werner from Germany. She is the designer of the first Passive House hospital. So really interesting conversation with Mary James and Ilka Cassidy about Petra's work and her journey to be this leading pioneer in hospitals and passive house. We've got the North American Passive House Networks conference coming up in just 2 weeks, as well as Passive House Open Days coming up soon. We've got FIAS events as well, Passive House Canada events. So you can see all these links and cool opportunities in this article. So I think that's it for me. I'm going to hand it off to Prudence.
All right. Thank you, Zach. So I have the pleasure of introducing Talina. She is an architect and certified passive house designer and director of her architecture practice, which is based in the Victoria region of Australia. And the core focus of her business is to create healthy, beautiful, and functional, and also comfortable architecture with an approach that combines building science and biophilic design, with the aim to move towards a more regenerative ethos. She's received many awards recognizing her meaningful contributions to sustainability and industry, and has an active role as board of director at Australian Passive House Association, also coordinator of Australian Architects Declare, and she also serves on the ARCA Team Advocacy Committee. She is going to share with us this episode her first certified passive house project, the Alwood Passive House, demonstrating what's achievable but also necessary for more climate responsive and responsible buildings. Welcome, Talina. Thank you for joining us.
Thank you so much for having me. It's an honor to be here as part of this global community.
All right, that's looking good.
Right,
Perfect. Thanks,
it.
Talina.
Excellent. All right. Well, I don't need to introduce myself, so thank you, Prudence, for sharing who I am. And really keen to share one of Australia's pioneering projects that we were involved with. So it was, the design commenced on this one back in 2016, so it's 5 years ago now. It takes time to do these things, but it was one of the first few architect designed certified passive house projects in Australia. So it really has become this case study, and we have received some recognition for that, which is great because we can share the love and explain how other people can then do that too, because some of the judges' juries were really saying that it did raise the bar for what's achievable in sustainable architecture, and we really want the rest of the Australian industry to raise up to this standard as well, because if we can do it, we figure everyone can. So I've got some challenges to share with you today, and the first one was around, these are the lessons that we learned along the way, and the first one's about not being afraid to push the envelope, and this was in terms of the site constraints, but also the building form and the design. So just really quickly, the map of where we are. Australia, south of the equator. We are down then in the warm temperate region, but we are considered a little bit cool temperate climate where we are. So it does get snow occasionally in winter, maybe once a year, so not a lot, but it still can get pretty cold. And in summer we get over 100 degrees Fahrenheit. It does get regularly quite hot. And the site we had was also in a bushfire prone area. It was a corner site that was quite large. There was woodlands to the south, and our solar access is to the north. So the challenges we had on this site was the fact that it was sloped from one side to the other on the diagonal. We weren't facing to our optimal solar orientation, and being such a large site, we didn't also want to just stick a little rectangular box in there, but really sort of spread out and have these outdoor rooms and outdoor garden spaces and connect to the landscape. So we did design this home as a solar passive design before we decided to turn it into or aim for certified passive house. So it is sort of stretched out. You'll see there's a lot of wall area. The interior, the central section is the living area with the 2-bedroom wings off to the side, and most of the services are grouped on the south in the middle because our solar orientation is to the north. Our treated floor area, 170 square metres, which is about 550 square feet, if I've done my conversions correctly. So at the end of our sketch design process, we approached a number of builders, the client and I, and that's when we met Stuart Lee, who was a certified passive house builder and had already completed a couple of Australia's first projects. And we just collectively decided that he was the right guy to join the team. And that's when we got on board a certified passive house consultant to help us out with our calculations. Because at that stage, I hadn't undertaken that training, but was super keen to see if it was possible to make this house a certified passive house. And you'll see all that surface area meant that we have not the best form factor, which meant we needed higher insulation, and we have got triple glazing just to make it meet the standard, and it was achievable. So we definitely pushed the boundaries of our own understanding of what sustainable means. Coming from that solar passive background, we had to reduce the amount of glazing we had because we had too much, and we also had already chosen not to have any thermal mass in this project. The aim was to, have less embodied energy. So there was the only concrete is the pad footings for the stumps, but the whole house is timber framed. So no thermal mass on the floor. And we did have an internal thermal mass brick wall, which we quickly scrapped because it wasn't actually going to give us much benefit. Coming from that solar passive design background, we wanted to make sure that our eaves worked perfectly, and they did for this diagram. And this diagram is perfect for summer at midday when the sun is shining on a particular angle, and winter at midday when the sun is shining on a particular angle. But it doesn't work for the equinoxes, and it doesn't work for those summer mornings and afternoons when the sun is in the east and the west. So our orientation meant that on the side here, these little wings or fins are actually very functional and they do work. But we then decided to put these external blinds on as well that are operable by remote control from the inside, and they work for all those other times of year. So that was a really big learning curve for us in terms of the passive house performance and the internal comfort. So yeah, just some closer up pictures of what I've just explained about that. The learnings and the clients love these and have really got to understand how they work for their lifestyle, which I'll explain a bit more later. So lovely high ceilings throughout this living area, and then the kitchen and the rest of the house have got the lower flat ceilings. The windows was definitely a big learning curve, ensuring that we didn't overglaze and had that balance, put fixed windows where we didn't need them all to be openable, and they were all triple glaze imported from Europe, and they're lovely. Another shot of the inside. The corner windows out. So this is out to the south. So for us, that's where we're losing all our heat and not getting any solar gain. And in the bathroom, the clients ended up putting some film on the windows. So we had to go back and check our calculations again, because that then changed the performance. And until the garden grows, they needed some more privacy. With the build-up and the construction methodology, I'll talk about that with some construction details in a moment, but it was definitely a learning curve in how to do this as a timber-framed project, trying to do the standard construction detailing, and this is the builder's suggestion, so we don't have a service cavity as such. All our airtight layer was outside the main frame, and the insulation was external to that. So our standard kind of 2x4 frame became the service cavity, and we ended up with some extra insulation in here as well, but we did have to get the woofy analysis to ensure we didn't have too much on the inside of the airtightness layer. And our subfloor installation got installed early on before any of the chipboard went down the substrate for the flooring, and it was sealed up, and it rained and got soggy and the builder had to drain it all out, and it dried out and it's all perfect now, but it was another learning for us all. We passed our blower door test with flying colours, and it was during construction that both me and my colleague decided to go and get our certified passive house designer training and underway as well, because we were loving everything that we were learning along the way. So that leads us straight into the second challenge of not being afraid to push out of our comfort zone. So we really did extend ourselves to learn as much as we could, and absolutely embrace the generosity of the passive house community. So we really did have to rethink how our standard construction details would work. So our typical wall is our standard sort of 90 mil frame, which is around that 2x4 construction, is my understanding. And this is these details, I've got the blue as our airtight layer and the red was our external weather resistant barrier there, vapor permeable, of course. So that's a lot of what we're looking at with the standard detailing, which is quite a lot of insulation in the floor and quite a lot in the roof. It was the walls that were challenging, because we usually find there's always room to fit more in the roof. And with a timber frame floor, it was easy, but this is so much deeper than what is standard. But yeah, the walls, which I'll talk more about, that's where it gets tricky and more expensive in our climate. So in terms of us learning to speak this new building science lingo, we really did love it. And for all the data nuts out there, I hope this makes sense to you in terms of, I have translated the R values just so you understand what we're talking about. But essentially for our roof, we would double what the code requirement is, same with the walls. And in the floor, we actually don't have a requirement for that to be insulated at all. Most of the standard construction here in Australia, residential, is slab on ground. And in our climate, they do ask for slab edge insulation, but not necessarily underneath. But for passive house, we absolutely are insulating our floor slabs or when it's timber framed. We really got to love using the PHPP and understanding what all these graphs meant. And it was really awesome to be working with a passive house consultant. So for us, that was Luke Plowman, who's one of Australia's 3 certifiers. So it was really awesome to work with him and benefit from all his knowledge. So with the code here in Australia, we have a star rating system for houses, and 6 is sort of the standard you have to meet. By the time you get to sort of 7.5, that's almost double the performance of 6, which is great. It's really awesome to be aiming for that level, but it does not take into account air tightness. It's heavily focused on thermal mass. It excludes sort of laundries or wet areas, and single glazing is still allowed. There's all sorts of different things about how, like, it is based on building science, but it's not the same as passive house. So we get this actual performance meeting predicted performance with PHPP, and that's what we love, because we can give that reassurance to our clients that they're going to get what it says they're going to get. And all the data is there for how we achieve this, and you can look it up on the passive house database if you like. We are ID 5851. And for us, the collaboration of this project was one of the most successful things about it. We had excellent clients, a really great team of consultants. That's Stuart, our builder, who's from Enna House, has changed his branding, but he's now one of Australia's most experienced passive house builders, because that's all he's doing and is in high demand. And he was really great to work with, because we all had this common goal, shared communication, and there was no such thing as a problem, because it was all about that, you know, solving only solutions and making sure that we all had that open communication and trust and respect. So it was a really great working relationship. So that global passive house community is what we love, and what we love about what you guys are doing with the Accelerator, because learning from each other has been the best thing. We really feel like we've found our tribe here in Australia. Love learning from what everyone else is doing as well. Okay, so challenge 3 was about not being afraid to push your expectations. And this is, again, in 2 different parts. One is about the client's expectations and that post-occupancy evaluation and feedback from their perspective. And then also about the expectations of what a passive house is, and will that solve the climate emergency? Is that as good as we can do, or do we need to be considering more? So these are our lovely clients, David and Yvonne, and this was their recent feedback about the benefits. They've been in the house a couple of years now. So, of course, all the things about passive house in terms of comfort and humidity control and less energy use. They love that there's hardly any dust or bugs now getting inside, and that it feels quiet and solid. They do have a lot of sticky beaks coming past because this project received a lot of attention. People do knock on the door at times, but please don't go and do that without checking first if you're in the neighbourhood. for them, it did become a bit of a Faraday cage because of the amount of insulation, but it's okay. They've got good Wi-Fi now and that's all sorted. But what they've realised too is there's a sense of dissonance and a disconnect from the outside, because if they're inside and nice and comfortable and they're looking outside, as soon as they step out, they realise that the weather outside could be quite different to inside, which is not the case of what they were used to and what a lot of our homes are like here, where often the outside temperature is kind of similar to what's inside. And for them too, David works from home, so he does really love this sense of active ownership. So not everyone likes that. But for him, it's the same as you would, open and close your curtains at the start or end of the day. And so he's sort of doing the same thing with those external blinds. And he does check all the weather and the data to allow for that. So here's the snow that did happen. Well, it happened last year as well, but it was the year before. And the interesting thing about this was all the neighbours' houses that were built in the subdivision, the snow on their roofs didn't settle. It melted straight away because they didn't have very well insulated roofs. Whereas here, it actually did settle and stay there for quite a few hours. And by the time it then didn't all make its way down to the gutters, they all bent because they weren't used to carrying the weight of so much snow and water. So we did fix that and get some brackets to sort that all out. But it's just not a problem we would normally come across in Australia. But it does make for a nice photo in the snow. And so that was some data from that day. Our clients do love collecting all the temperature data from inside. So you can see down there the outside temperature we've got down to freezing just before, overnight before 6 a.m. But inside it did remain comfortable. It did dip down a little bit lower than comfortable, but it's still that lovely range, whereas most houses would be probably quite uncomfortable. And again, our clients collect all this, and this data was really helping them to understand what this house, how it was going to perform, what they needed to do, because the heating and cooling that they have is a split system, air conditioning, reverse cycle unit, the heat pump, and they didn't, I believe last summer, they didn't use it at all, maybe once. We did have a summer that didn't get too hot. And in winter, I think it goes on for an hour or two before they wake up in the morning to heat, just to take that edge off, and then it turns off and they don't need it. So if there's a beautiful sunny day, they do open up all those blinds, but sometimes they've discovered that it could get too hot. So the honey I bottled, the dog, Yvonne was home on her own, and she locked the dog in one of the front rooms, which receives all the sun, accidentally. And then she came home at the end of the day. Poor dog ran out sweating and parched, desperately needing a drink, because it did get up to 30 degrees Celsius. I'm sorry, I'm not sure what that is. Quite hot for inside. And they realised that it really could spike to that temperature without any active heating at all, purely based on the solar gang coming in. So on those days, if they know it's going to be quite hot, they leave the doors open or potentially close some of those blinds, even in winter. So that was in winter. And when they were out of the house for a couple of weeks on holiday, it did drop down to quite cool, just because there wasn't that internal heat gain for them. And they did have all those external blinds closed for privacy. So it's been really interesting hearing their feedback. And David watches all the data because he likes to sort of know what's going on, but that's him. And most of those early adopters in Australia absolutely have been the data geeks who really love this, but that's definitely been shifting to now being all about everyone understanding and appreciating the healthy home and the comfort, not just the data. Yeah, they love that they have this sort of evidence now about how that HRV works and all the dust and bugs that's excluded from the home. And when we had bushfire seasons as well, that they weren't close to any fires recently, thankfully, but there was some smoke that came nearby, and their house performed really well compared to the other homes in the neighbourhood. They love that the condensation happens on the outside of the windows, not inside, which is often the case here. And their little hoist clothes rack there in the laundry means everything dries really quickly. The clients are super proud of what's been achieved. They love that their house is admired. But really, also that our collaborative process was envied, which is really lovely. We had a lovely experience. So in terms of what we know, a passive house can be comfortable, healthy, low energy, quite resilient. They are all awesome things to strive for. But for us, we wanted to take it that step further in terms of that biophilic design, choice of materials, connection to nature, the views out, and being able to step out into those gardens. Water use as well, of course. And it's an all-electric home, and they have put the solar PVs on now. They didn't at first. They wanted to understand how big a system to put on. We did consider embodied energy where possible. As I said, no concrete and mainly timber, or the cladding being readily sawn timber, and then the recyclable metal that doesn't need any maintenance. And also for them, it was the adaptable, flexible use. So the 4 bedrooms don't have built-in robes. They can be used as a snug or a little sitting room, as guest rooms, as office. So they wanted that flexibility throughout the home. So really for us, it's this holistic approach. What else can we do beyond passive house? So yeah, this was an all-electric home as well, no gas connection. That's the solar heat pump hot water and the air conditioning unit, and the solar PV array now on the garage. And that biophilic design has extended out into the garden. They've got trying to increase the biodiversity and encourage local wildlife. They do have kangaroos come and visit from the nearby woods. They've got a billabong to try and increase that. So the garden's starting to take shape, which is lovely. And as I mentioned, for us, we know that being net zero carbon and passive house is absolutely where we would love the whole industry to be, but we're now keen on and moving towards just doing less bad, and how can we do more good, and what might that look like in the future. So here's some of the other current passive house projects that we're working on. Some are on site now, which is exciting, and others are still on the drawing board. But we've got a bunch of different things happening, including a multi-residential development. And we're only a small practice of, we've got 4 women at the moment, so we're quite small, but we're also in the process of hiring. So we can only do so much, which is why we're keen on sharing what we've learned so more people can do this as well. Quickly about these wall details, what we're finding with the number of projects we've been documenting is that we keep reinventing the wheel, and every single project has been slightly different. But I just wanted to illustrate this first option here is kind of our code wall, and sometimes this external cladding might be brick veneer quite commonly with an air gap here, but there's no airtight requirement, and this is how thin the walls are. And our friends who are up in Sydney and other milder parts of Australia, they can kind of get away with this same detail with no extra insulation, making it airtight and meet passive house. And we know people who have done this sort of detail as well, whereas our project, some of them are moving right down the bottom here to 300 millimeter LVL stud framing, so a foot big, a foot wide, to get enough insulation in based on a particular project and its form and its volume and everything, and its climate. That's how much our wall needs to change. And we've also got a couple of projects where we're using straw bale prefabricated panels, again, to reduce that embodied energy, but much, much thicker walls. So it's a big jump from what sort of the standard is in Australia to different ways we can achieve passive house. And we haven't gone down the path of CLT or SIPs yet. We're about to look into SIPs for a project, but really interesting that at the moment we haven't found one right way to do things, so we keep learning new ways. As I mentioned, the roof's easy to deal with, timber frame floor is easy, concrete slab, we're dealing with that a few different ways, whether it's insulated underneath, or some of our current projects have got structural slab, XPS insulation on top, and then a non-structural screed or topping slab. But for us, that's 2 concrete slabs, so we don't know that that's necessarily ideal either. All right, and almost wrapping up here, as Prudence mentioned, I am really keen on advocacy in the community, so I love these opportunities to share and promote passive house to a wider audience, and I'm very involved with Architects Declare and helping spread that message. So for us, the awards were lovely, but that's not why we do what we do. It really is just giving us that platform to be able to talk more about Passive House. And that's also why I ended up on the board of the Australian Passive House Association. And last year we were involved with pulling together this book of Passive House in Australia, and I'll put the link in the chat there, because if you're interested to see all the other amazing things that are going on in Australia, this book has 25 or 30 of our case studies from the first certified projects, and I believe the current figure is 40 officially on the database, but we know that there is hundreds, talking to the certifiers, that are underway and in different stages, and also people choosing not to be certified as well. So there's a lot happening in Australia, and it's exciting to see where it's going to go. And that is me.
Thank you so much, Talina. That was fantastic.
You're welcome.
Did you have fun?
Yeah, absolutely. I'm keen. I couldn't see the chat, so I'm keen to get stuck into some questions.
Oh, yes, there are questions. So Sean is going to have the questions lined up for us, and we'll start with 20 minutes or so, 15 minutes or so. And then at the top of the hour, if you can stay, we would love to have you, but we know it's a different time and you might need to get on with your workday.
I'd love to chat.
Awesome. So we'll roll into the after hour at the top of the hour. And with that, I'll hand it over to Sean.
Perfect, thank you. So it seems most of the majority are drinking coffee right now, but the rest of us are drinking something else. So wherever you are, enjoy your beverage. Talina, have a sip of whatever you're having. And since most of you actually went and grabbed your beverage, why don't we just kick off the questions with just giving you a big cheers. So thank you for spending the time and presenting this really cool and fascinating project. And I know, disrespecting the cheers. I laughed at myself again today because you're talking about north, and I'm like, it should be south. And then of course you reminded me that I was in the wrong orientation. So
I tried to add those extra slides and just briefly explain it, but yeah.
Yes.
Confusing.
So, and then, all the people that are down south are like, Sean, what do you mean? Like, this is just how we are. North is important for us. So let's kick off the questions. Jeff Rodine, you get to kick it off, my friend.
Well, first of all, that was a great presentation. It was a nice mix between the aesthetics and the building science geekiness, and I'm on the building science geekiness. So the first question is the shading. I thought the strategies were really interesting, and the external shading in particular. So I'm curious what the product was and what the controls were, and did you how many did you look at and all that kind of stuff.
Oh, interesting. The clients actually chose those themselves, and they loved that they are aluminium, and they're louvers that can either tilt sideways and also go up and down. So you can really adjust them for that sun angle if you want, say, a bit of privacy from the neighbours or the street out front, but still want that solar gain. Yeah, they are all adjustable. So they've got 4 identical ones, and they've got a remote control inside that just operates them all. Can't remember the name of the brand, sorry.
That's right.
They, yeah.
So they decided it's getting hot, we need to shut the.
Yeah, so we did model them in the PHPP early on, and that our consultant said, look, you're going to want this extra shading, which we all went, really? Because, we're so used to our houses being so cold, and this idea of letting all that northern sun in, that's what been one of the biggest learnings in Australia. I think that we're just not used to having this degree of comfort, and this idea that these passive houses can overheat here is a real issue. So having that fixed shading, as I said, it works at those certain times of the day and the year, but it really doesn't for all scenarios. And this particular project was on that borderline of meeting compliance. There are plenty of other projects happening in Australia that don't necessarily require this external shading, but yeah, for this one we did. And we just like that it's adjustable, because then you could get away with not having those heaves at all then.
And they didn't find that it took too long for the house to cool down after they boiled their dog.
No. Poor dog. No, they just got used to learning how that they did need to operate it themselves, and they love that about the house, because they now know how it works. but I understand that a lot of the passive house communities, the whole point of it being passive is you don't need to have that active involvement. So we are interested in how to achieve that, and love learning what other people are doing, because the shading is a big requirement here in Australia. I suppose where we have problems is the equinox too, because for us, when it's coming out of summer, it can be still really hot at the equinox and the sun's so much lower in the sky. But after winter, when you get towards equinox, you really do want that sun coming in. So it's just working with our temperate climate and dealing with those extreme temperature differences.
Perfect. Great. Thank you very much.
Thank you.
And it's great to see that you guys have adopted kind of the exterior shades a lot earlier than us North Americans, because we talk about the Pascal's principles. We talk about high performance windows, and I always like to put in brackets exterior shading when I talk to people, because we just don't get it here yet. So learning fast enough. And now we're gonna move over to Susan. I think Susan's question was answered, but she's usually always has some question.
Oh yeah, I'll get another one there. But you put my name in there. I'm definitely gonna ask. And Talina, yeah, I'm second what Jeff said, that I love the balance between the aesthetics and the geekiness. That was a lovely rhythm, and thank you so much for that presentation. So yes, I really actually didn't have a question, but it will be about the billabong, and I was corrected in the chat. I was mixing it up with a wallaby. True. Billabong is a creek, a pond. I had trying to translate all the time. So yeah, that's it. Billabong's a creek, wallaby is a kangaroo. That's it. Thank you.
Correct. I should have said pond or dam, but yeah.
No, love it. You gotta get us out of our caves here.
Yes. We needed some culture. We're all in our little rooms here, so it's nice to get a bit of culture. So it's great to have those discussions. All right, thanks, Susan. We're over to Hans.
Hey, Talina, this is a great presentation. My question was about the sensors. What did you use to monitor the house?
Again, this is our amazing client. He's got his own sensors that are placed in 4 different locations throughout the house that are testing temperature, humidity. We have got some CO2 sensors that we have been meaning to put in, and that's my fault that I haven't done that as well, because we are also keen on monitoring that. But he just links it all up to an app and keeps track of that himself.
Okay, cool.
Yeah.
Thanks.
I was going to say, and it's one of the few projects in Australia that we did use all Sega products because the builder is really familiar with them and loves them, whereas many other projects are using the ProClimate products, and others in the industry are coming on board too. So there you go.
Yeah, it was good to see.
Excellent, thank you. Patricia had a couple. Patricia? Yeah, Patricia, sometimes your audio doesn't work.
I got a new computer.
Go for it. Great.
Yes, it is great. First, I want to say the scale of the living room and the dining room vaulted ceilings was so special. Usually the vaulted ceiling, it'll cover the whole area and it's huge and beautiful, but what you did was special. My question is the material under the insulation in the floor.
So that was just our external wrap. It was just the WRB that was wrapping around the entire building, and that's what held the water. Even though it's vapor permeable, it did hold the water when it rained before the house was completed. That was during that framing stage.
Yeah, I'm sorry, I missed the beginning of that. If you could just tell me again.
So sorry, it was just the weather resistant membrane, the external, sorry, I've forgotten what the name of the product actually is, but just our external wrap.
Thank you.
Hans, would you like to comment on what that wrap is?
It could have been my vest.
Yes,
if it was
MHA. MHA, yes. Yeah.
Could you put that in the chat so we could see how it's spelled, please?
And Patricia, you can get Hans' contact info and he can help you out immensely. So you can reach out to Hans. And now we're moving over to Hans, you had another question, but I think it was more of a comment. Are you good? Yeah, okay. And then
Can I just jump in and explain?
Sure.
Sorry, with the subfloor installation, there's many ways that people or builders have done that here in Australia. So it made sense to use those bats, the insulation bulk bats, for cost effectiveness. But it was just how to keep them in place, and they thought it would be a good idea to wrap it all first and work from above, but that wasn't necessarily the case. So I hope that makes sense, how the process of how that worked.
I'm sorry, excellent. Moving along. Enrique, your turn.
Thank you. My question was partially the answer here, but I still have a doubt about how did you apply that WRB underneath the insulation there? Did you, because the floor seems to be sitting like on a steel post frame and or metal frame, and did you tape the WRB to that metal frame, or how? Or did you apply?
Yeah, so there were steel stumps, so concrete footings. There were steel stumps that came up out of the ground because we got too high to use timber ones there and concrete as well. So it made sense to have the steel stumps or posts, if that's what you call them. But then everything else above that, so where from the bearers up, was all timber. So the builder did wrap that all around and tape and seal it. So the order of that was putting that wrap first, and then all the bearers and joists went on top. Then he put the insulation in so that it would sit and be held in place because of the wrap. And then they put down the chipboard substrate on top to start working from. And then one day when that rained, they discovered that the chipboard was not watertight. It works pretty airtight, but not watertight. So enough moisture got through to then make that insulation damp and saggy. So they did have to cut the wrap open underneath to let it all drain. And they did have, I think, a couple of little wires in place as well, just to keep it in place. But they waited then till right at the end of the project to seal it back up again, because that's not really the airtight layer. That the airtight layer was more on the the internal side. In our climate, that was more the external vapor permeable wrap to just keep it in place and then keep the insulation all nicely sealed and covered up.
Oh, so that's the reason why the insulation looks exposed at that in the picture. Or so it
Correct,
was taken
yeah.
when it was.
Yeah, that was when it was drying out. When we were learning about, oh, here's not what to do next time.
Okay,
Yeah.
thank you.
Yeah, we like to share our failings so we can learn from them as well. Don't do it this way.
Yes, indeed. Sharing is caring. Thank you for that. Because again, now people know, okay, maybe we need to, maybe not tape it, make sure that's on and connected, but maybe leave a little bit of water holes until things can get figured out. But again, at least the floppy bits were installed and so it can connect on. So next one is Carol Parr. And Carol, for those that don't know, our good old friend Harvey. Harvey always asks about the cost of things. So you have the Harvey question of the evening. You probably didn't know that, Carol, but go ahead and ask your question.
Oh, I sure knew that one, Sean. I was really glad to be in Aussie to ask this question. So you're
That's
in.
That's why
this.
I'm letting you have it. So go for it.
Okay, Talina, the question is how much per square metre did it?
Well, this comes down to what you consider square metre. Do you consider square metre as the treated floor area, so that internal floor area? Do you consider that as the external building footprint? Do you consider that as the roof overhang? And so it is really hard to explain what that square metre rate is because everyone calculates it differently. In terms of what the cost was, it was comparable to any other custom designed home. It's just that we focused on putting that money towards the building envelope, and as I said, there was less built-in joinery, just smart decisions with materials and things. So it was still a lot more than a volume build or a non-custom build, but yeah, comparable to other architectural projects that was on par, if that makes sense.
Yeah, it does make sense. It's just that I was trying to do one here in Sydney on a granny flat, 60 square metre, and we were blowing the budget per square metre. And I've been in Passive House since the beginning with these guys, trying to figure out what it was costing. So, so I was just doing it basically on the whole granny flat, if you get what I mean.
So of course, when it's a smaller, sorry, I was gonna say, a smaller project has a higher per square meter rate as well, because you've still got a kitchen and a bathroom and all the plumbing and all the electricity. So what we are finding as a vague square meter rate down here, it could vary between $4,000 and $6,000 per square meter. So a 200 square meter home, you know, you're looking at 800,000 to 1.2 million as an example. And I don't know, sorry, for the Northern Hemisphere, how this translates with all of your square feet and costs. But this is also, as I explained, in our climate, it is more difficult to achieve passive house. There's a lot more costs in that bigger structure, bigger insulation, of course, windows. But in Sydney, you guys can get away with almost doing the same construction. So you should be able to do it more cost effectively. But happy to have a chat offline at another time too, Carol, if you'd like to.
Oh, that'd be great, Talina. Yeah, we came in at 5,000 per square metre.
That sounds pretty
yeah,
good.
And that's, yeah, okay. It just sounded a lot at that time.
That's kind of custom homes, I think. And the moment post-COVID, I mean, I know we're still in COVID, but post last year, the materials and labour are just increasing everywhere, and I hear this global. So I don't know what's going to happen in the next 12 months with costs of projects either.
Yeah. Okay, cool. Thank you, Talina.
Carol, thanks for that. And Talina, I think we're going to record your answer. And every time that Harvey asks the questions, we're just going to play your clip so that he has the answer. And then when he really wants a number, we'll give it to him in square meters. So then he's got to convert it just as the result. And since he's not here tonight, we're all in this, 101 of us. We will do this next time Harvey shows up and pulls out his lovely question. We love Harvey. We love that he asked the question, but now we got some zingers for him. So look out, Harvey. Thanks, Carol. And we're going to go to Zach to wrap up the happy hour.
Great. Thank you very much, Talina. This is amazing. I can't wait to hear more. I just wanted to say to everyone that if you appreciate the work that the Accelerator does, if you believe in the mission of accelerating passive house, if you enjoy these happy hours, then you have a lot in common with these organizations here, because they do too. So we have a big debt of gratitude at the Accelerator for the support from our sponsors. Our founding sponsors are 475 High Performance Building Supply, Backstingui Architects, Mitsubishi Electric Train HVAC US, Partel, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC and Dehumidification Units, RDH Building Science, Rockwool North America, Stocorp, and Zola Windows. Our champion sponsor is SIGA. Our stakeholder partner is NYSERDA, the New York State Energy and Research Development Authority. And our patron sponsors are AeroBarrier, BR+A Consulting Engineers, Brennan Insulation and Airtightness, Innotech Windows and Doors, and US Engineered Wood T-Stud.